Good morning. Welcome to the SCI-Compiler tutorial. In this tutorial we will learn how to create a discriminator using this CDK development kit. In this first tutorial the discriminator will have a fixed threshold inserted in the firmware, hard-coded in the firmware. We will use the following setup. We have the CDK board, a DT4800 micro emulator, and an oscilloscope. The emulator generates an analog signal that is provided to the CDK board and also to the oscilloscope using this split T. And in the board we will acquire the signal using the ADC. We will compare the signal with a fixed hard-coded threshold, and we will drive the LEMO output in order to be high when the signal is over the threshold. Okay, this is SCI-Compiler. We create a new project. We choose to save it in the standard folder. We select the board CDK and we assign the name to the project as CAEN SK001 underscore discriminator. Okay, now we can create the project. Okay, so now to implement the discriminator function, we need to compare the analog input with the threshold. So the first thing, we have to place in the design the analog input. So from board pin toolbar we select analog in. We can now move it, and also we can select a block by right click on the diagram, toolbar, and now we choose comparator greater. The system asks us to specify the settings for the comparator. Our comparator will be a 16-bit comparator, unsigned, mode great, you can choose also greater or equal. And if we want a register output in order to make it synchronous with the clock, we just use the standard settings. Okay, now we can connect the analog input with the comparator. We have to place a fixed threshold, so from the toolbar we select MISC and then constant bit vector. We have to set the size of the bit vector, so the number of bits that should be compatible with the analog input, so it's 16, and the value for the threshold we choose 3000. We can also insert in hexadecimal or in binary as the help explained here. Okay, we can connect the fixed threshold to the input 2, and now we have to connect the output with the LEMO output. So we choose LEMO and LEMO 0. This is the LEMO 0 output, and we can connect it here. LEMO, if we have a look to the online help, is a bidirectional device. So we can select if the LEMO is an output or an input. If we set it 0, the dear output pin, the LEMO will be an output, while if we set the dear output to 1, the LEMO will be an input. Leaving it unconnected, the default is 0, and so the output, the LEMO, is an output. For a visual effect, we can also connect the digital output, so LED 0. So we have also a LED that will be on when the signal is over the threshold. Okay, there is no register, there is no memory mapped peripheral, so we can just proceed to compile design. We go in Home and press Compile. SCI-Compiler now asks us to start the compiling process. In the first phase, it will generate our project and VHDL, and then it will invoke Vivado, Xilinx Vivado, in order to generate a valid bit stream. As soon as the system complete the bitstream generation, on the last line of the log will appear successful compilation. At this point, we can load on our hardware the bitstream that the Vivado generate. Okay, first of all, we need to put our device in bootloader mode. In order to do it, we have to disconnect it from the USB, move the red switch on the right position, okay, and then connect the USB again. The blue LED light on and stay fixed blue. When the LED blink, it means that the board is in application, so it's running your firmware. When the LED is fixed blue, it means that it is in bootloader, so you can upload a new firmware. Now we have to convert the bitstream generated in Vivado in a new file, that is a file that can be loaded on the board using the bootloader tool. So we can press generate flash file, okay, and now we can press flash program tool in order to open the open hardware programming tool. We select CDK, we press next. The tool find automatically the board, so it displays the serial number of the board, and now it is already programmed by the SCI-Compiler to download the last firmware that has been compiled. You can just press start, and the tool will download the firmware on the board. Okay, once the firmware is downloaded, you can either press boot application from the SCI-Compiler open hardware download tool, or you can disconnect the board and move the switch on the right. Now it's more fast to just press boot application. The LED on the board the blue LED on the board start to blink. And it means that the board is correctly programmed and is executing your firmware. Okay, at this point we can have a look to the oscilloscope. Now you can see the exponential signal generated by the emulator, and on the blue track is the digital output of the board. So the signal, it looks like that the signal is too small, and so it is below the threshold of the comparator. In order to increase the threshold, we can operate on the emulator detector emulator control panel and increase the amplitude of the signal. Now we have no digital output, and if we increase the amplitude, we can see that the blue channel, the channel 2 of the oscilloscope, now is commutating and is over the threshold for the time that it's high for the time that the signal is over the threshold. Okay, that's all for this tutorial. Okay, thank you.